This is Intro to Proofs, section 6.5. We're looking at sets A, B, and C, where capital A is ABC, capital B is ABCD, and capital C is PQR. And we're given some function rules defined on the bottom of page 321, and we're going to draw an arrow diagram for each function. So for A, which is A, B, C, to B, no, A to C, C being PQR, and F takes A to R, and B to P, and C to Q. That's F. Okay? And then B, or G, sends A, B, C, to C, which is PQR, and it sends A to P, B to Q, and C to P. Okay? And then H sends, goes from B to C, so it's A, B, C, D, and it's going to C, which is P, Q, R. This was G. And then H goes A to P, and B to Q, and C to R, and D to Q. Okay, so there's our arrow diagrams. Determine the inverse of each function as a set of ordered pairs. Okay? So I can come up with ordered pairs that kind of reverse the relation. So here, F would be, the inverse would be PB, QC, and RA. And G would be would equal, G would be A or PA, PC, and QB. Okay, and this is H up here. So then H would equal PA, QB, QD, and RC. Okay. All right, and these are the inverses, not the original functions, because I'm swapping the order of all the ordered pairs. And so the question then is, which of these are inverses? So this is an actual inverse function. Like this inverse is a function. This inverse is a function, not a function. Why? Because, well, two reasons. P goes to two things, and R goes to nothing. There's nothing for no over R ascent. And then H inverse is not a function because Q is sent to two things. So Q is sent to two things there, P is sent to two everything's there, and then there's no R. Okay? So those are why those are not inverses. Draw an arrow diagram for each inverse in part 3 that is a function. Use your existing arrow diagram for part 1 to draw this arrow diagram. Okay, so the inverse arrow diagram is right there, there, right there. Okay, so what do you think is a condition for a function to show its inverse? Its inverse is a function. Well, notice that this function is not this function is not injective and not surjective. This function is not injective. So not injective doesn't work. And also not injective and not surjective doesn't work. Not injective means you end up with having to send something to two things. Not surjective means you got something that has nowhere to go when you try to make an inverse. So it needs to be both of those, and we call that bijective. So in order for a function to have an inverse, it must be a bijection.